Today we'll expand our understanding of transformations by doing a few rotations. And we'll use this experience to understand how transformations can be understood in terms of numbers and algebra. Transformations are all about exploring different ways that you can move a point from one location to another on a grid. But today we'll define precisely how this happens. So this happens through a transformation, which includes rotations, translations, dilations, and reflections. And these all involve some mathematical function which describes how a point, line, or shape can get from one place to another. A rotation is when a point or shape is rotated around a point or center of rotation. The only important parameters in the function are where the center is. In our case, it's going to be the origin, 0, 0, and then how many degrees the rotation is. That is the angle of rotation. So we can rotate things by 90 degrees, 180 degrees, 270 degrees, or you can go all the way around and do 360 degrees, which is the same as 0. Positive rotation is going to go from quadrant 1 to quadrant 2, 3, or 4. So this is always going to be positive rotations will always be going counterclockwise. So for the first exercise, we'll do a rotation with the points listed, and then do a 90-degree rotation around the origin, point 0, 0. Now that we're done, you'll notice that the resulting two line segments still form the same angle and still have the same shape. Another thing you'll notice is that the new points that are made follow a sort of formula. For the new a, the negative of the old y is the new x, and the old x is the new y. And this is true for the other points as well. Just from doing this one rotation, we've discovered two things. One is that the angle and line segments are all congruent, and there's this new formula where the negative of the old y is the new x, and the old x is the new y. Alright, so now we're going to do a more complicated shape. For this, we'll graph line FG, which goes from negative 4, 0 to negative 2, 2. Then we'll graph the line HI, which goes from negative 2 to 0, 0. And then we'll connect all these endpoints together. If you did this all correctly, you should get a square. And now our task is to rotate this by 90 degrees. But first we'll algebraically plot the points. That's right. From what we discovered from the last exercise, we can determine where these new points will be. So according to our new formula, the new f will be 0 and negative 4. The new g will be negative 2, 2. The new h will be 2 and negative 2. And the new I will just be 0 and 0. And now we can see that this is still a square, and that the 90-degree angles are the same, and that the shape is the same as before, just in a different orientation. So the main takeaway from all of this is that we can determine the new points in a 90-degree rotation without doing the rotation itself, and that the new shape will be congruent to the old shape.